All right, if you're a process engineer or a grad student digging into chemical engineering, you already know this. In the world of oil and gas, managing risk isn't just a part of the job, it is the absolute bedrock of everything we do. Today, we're going to dissect two of the most foundational methodologies in process hazard analysis, HAZID and HAZOP. We're going to get right into the strategic framework that keeps these massive, high-hazard facilities running safely.
So here's our game plan. First, we'll set the stage by really defining the problem of major accident hazards. Then we'll break down HAZID, looking at it as our first line of defense. After that, we'll do a deep dive into the incredibly meticulous HAZOP study. Then the really cool part, we'll see how they work together. And finally, we'll connect all of that qualitative work to the hard numbers in the world of SIL determination.
Okay, so first things first, we have to talk about managing major accident hazards. Before we can even begin to compare the tools, we really need to understand the environment we're in and the fundamental problem these tools are built to solve, which is managing the risk of a catastrophe.
Look, in the hydrocarbon sector, we're operating at insane pressures and temperatures, with huge inventories of highly volatile materials. That combination creates a very high consequence risk profile. A major accident hazard, or MAH, is one of those low-frequency but terrifyingly high consequence events, and it's something that has to be systematically identified and controlled. The potential for a catastrophe means that it won't happen here just isn't an acceptable engineering stance, period.
And let's be really clear about something. Doing a process hazard analysis isn't just, good engineering practice. It is a global regulatory mandate. From OSHA's Process Safety Management Standard right here in the US to the SEVISO Third Directive over in Europe, the authorities demand a systematic approach. And it's methodologies like HAZID and HAZOP that give us that meticulous, auditable trail that proves we've done our due diligence.
So that brings us to our first methodology, HAZID. I want you to think of this as the high-level strategic first pass. It's an absolutely critical tool for catching major hazards as early as humanly possible in a project's life. At its core, a HAZID is a structured workshop. It's where you get a cross-functional team in a room to identify hazards before they get locked into the design. And its real power, its greatest value, is that it enables what we call inherently safer design. Now, this isn't about adding more safety systems later on. It's about making fundamental design choices, like maybe substituting a hazardous chemical for a safer one, or designing the process to run at a lower pressure, that literally eliminate or reduce the hazard at its source. And the strategic value here, well, it's all about timing. A HAZID is done during the feed stage, when all you have are process flow diagrams and some general layouts. And that is a huge advantage, because you can use a checklist approach to find the big hazards, everything from process upsets to external events, and you can make changes before any serious capital gets committed. The main output is the hazard register, and that document becomes the foundational risk Bible for the entire project. Okay, now once we have a mature, detailed design, the game completely changes. We shift from that broad screening of the HAZID to the forensic, almost microscopic, deep dive analysis of a HAZOP study. A HAZOP is an incredibly structured, systematic breakdown of a process. Its entire goal is to rigorously challenge the design by identifying every single credible way it could deviate from its intended operation. And what's crucial here is that it looks at both safety, preventing incidents, and operability. Now, why both? Well, think about it. A process that's tough to operate or is always having upsets, it forces operators into non-standard situations, right? And that is a direct path to human error, which can lead to major incidents. Now, to be effective, a HAZOP needs the details. We're talking P&IDs, control narratives, the works. The process itself, which is guided by the IEC 61882 standard, is incredibly disciplined. First, the team breaks the whole plant down into manageable chunks called nodes. Then, they systematically apply guide words to different process parameters to brainstorm deviations. And for every single deviation, they have to identify the causes, the consequences, check the existing safeguards, and then, if the risk isn't controlled, they make recommendations. And right here, this is the real engine of the HAZOP. This matrix isn't just some static list. It's a creative but systematic tool. By forcing the team to combine a guide word, like more, with a parameter, like pressure, or reverse, with flow, you start to uncover scenarios that your intuition alone would absolutely miss. This structured brainstorming is what gives the HAZOP its rigor. It's what gives it the power to find those hidden failure modes. So, this brings us to a really crucial point. You don't choose between HAZID and HAZOP. They aren't competitors. They are partners in a powerful,
tiered strategy that helps you optimize your engineering resources and maximize safety across the entire project lifecycle.
And this table just perfectly illustrates their distinct but totally complementary roles. Just look at the documentation row. HAZID is the broad, high-level screening tool you use early on when you only have PFDs. Its job is to spot the big picture hazards. HAZOP, on the other hand, is the focused, systematic verification tool. You use it late in the design, and it requires those detailed P&IDs to analyze every potential deviation, right down to the individual node level.
What this does is it creates a highly efficient workflow. The HAZID happens first. Its output, that hazard register, it identifies the systems with the highest risk or the most complexity. And this allows the project team to focus the incredibly resource-intensive HAZOP study precisely where it's needed most, instead of trying to, boil the ocean. You can think of it like this. HAZID tells you where to look, and the HAZOP tells you exactly what to look for. All right, let's move into our final section. This is where it all comes together. We're going to see how the qualitative findings from our HAZOP get transformed into hard, engineered safety requirements through a quantitative process. So this is the million-dollar question, right? We've identified all these hazards and deviation scenarios, we've assessed them qualitatively, but how in the world do we translate that knowledge into a specific, calculable performance requirement for our safety systems? The answer is a methodology called Layer of Protection Analysis, or LOPA. LOPA is the bridge that connects the qualitative world to the quantitative world. And this is so important. The integrity of any LOPA is 100% dependent on the quality of the HAZOP that came before it. It is the definition of garbage in, garbage out. At the very heart of LOPA is this calculation. This is what determines the required performance of a safety instrumented system, or an SIS. It calculates the required probability of failure on demand, or PFD. Let's break it down. Think of it like this. The formula answers the question, how reliable does our automated safety system need to be? And it does this by comparing the target risk, which is the maximum acceptable frequency of a very bad event, with the intermediate event frequency, which is how often that bad event would happen if we only relied on our non-automated safeguards. The gap between those two numbers, that's the performance required from the SIS. Now just look at how directly the HAZOP feeds this entire process. The causes you identify in the HAZOP, that gives us our initiating event frequency. The consequence severity, that determines our target risk. The safeguards that are identified, those become our independent protection layers in the calculation. And critically, the HAZOP worksheet has to flag any scenario that places a demand on an SIS, which creates a direct, auditable link to functional safety standards like IEC 611511. This quote from the source material really says it all. The responsibility on that HAZOP team is just immense. A flawed qualitative judgment, maybe overlooking a cause or overstating how effective a safeguard is, it doesn't just stay on paper. It cascades directly into the math, and it can result in a dangerously under-designed safety system, one that will fail when it is needed the most. So let's just quickly recap the crucial takeaways. HAZID is your broad, early-stage screening tool. HAZOP is your systematic, detailed design verification. They work in synergy, with HAZID scoping the work to make the HAZOP more efficient. And most importantly, the HAZOP provides the non-negotiable qualitative foundation for quantitative methods like LOPA and the ultimate determination of a safety integrity level. And that really leaves us with a final thought to chew on. At their core, HAZID and HAZOP are human-centric, workshop-based processes that rely on collective expertise. So as our facilities get more and more complex, more automated, how will these essential analyses need to adapt and evolve to keep pace and to guarantee safety for the next generation? Thanks for joining me for this explainer.